Good day, everyone. My name is Arshalin, and today on our virtual class, we are going to talk about smart concrete. What to be discussed are what are smart concretes, type of smart concretes, list of smart concretes, and its application. What is smart concrete? Concrete is one of the most common construction materials in the world, with its basic technology dating back to the ancient Romans. By adding carbon fiber to concrete mixture, a slab of concrete is able to conduct electricity. Smart concrete technology offers an alternative method for monitoring the health of reinforced concrete structures. It was developed by Dr. Deborah Chung from State University of New York at Buffalo, US in 1993. Smart concrete has many potential applications, including helping structural engineers to identify trouble spots in the concrete structure long before stress or cracking is visible to the human eye. The unique benefit of smart concrete is that it is fortified by carbon fiber, which comprises as much as 0.2% to 5% of the volume. This can detect stress or strain in concrete structures before they fail. Smart concrete technology has undergone extensive laboratory testing but is yet to hit the market. How does it work? It works by adding a small quantity of short carbon fiber to concrete with a conventional concrete mixer to modify the electrical resistance of the concrete in response to strain or stress. As a result, the contact between the fiber and cement matrix is impacted when the concrete is deformed or stressed, thereby affecting the volume electrical resistivity of the concrete. The strain is then determined by measuring the degree of electrical resistance. Smart concrete is capable of sensing very small structural flaws and hence finds applications in checking the internal conditions of structures, particularly after an earthquake. Normally, for producing smart concrete, the fiber content is 0.24% in volume, silica fume content is 15% by weight of cement, and methyl cellulose is 0.4% by weight of cement. What makes it different? Conventional concrete does not have self-sensing properties to detect cracks in structures. Smart concretes are intelligent systems that have properties different from normal concrete, such as self-sensing and self-healing properties. In order to detect cracks, sensors have to be fitted inside the buildings, which is quite expensive. The existing sensors like strain gauges, fiber optics gauges, piezoelectric, acoustic emission, Bragg rating also suffers from poor durability and the requirement of trained personnel, transportation, and erection problem. There are mainly two types of smart concrete. The one is smart concrete made from soft carbon fiber, and the smart concrete made from carbon nanotubes or CNTs. Typically 5 mm carbon fiber are being used. Fiber content is 0.2 volume percent of cement, silica fume content is 15% by weight of cement, methyl cellulose content is 0.4% by weight of cement. The advantage is that short carbon fibers, due to its conducting property, senses resistance change, and it is also high flexural strength, which is an added advantage. Moving on to the smart concrete made from the carbon nanotubes or CNTs. As we know, carbon nanotubes are having high flexibility. The diameter of CNTs are in the range of 1 to 20 nanometers and the length range from 0.2 to 5 micrometers. Because of its flexibility and its microstructure shapes as tubes, it is capable of bending in circles, and thus, it helps in forming bridges between the cracks in the cement, which means that it increases the strength of cement composites. It also causes high elasticity tensile strengths and yield strains and can be used as a reinforcing materials for concrete. Also, the piezo-resistive properties of CNTs enables the composite to detect the stress strain inside the pavement. Smart concrete is a very broad category of material that includes self-sensing concrete, self-adjusting concrete, and self-healing concrete. Some of the branches are transparent concrete, high-volume fly ash concrete, silica fumes concrete, self-healing concrete, polymer concrete, self-compacting concrete, bacterial concrete, fiber-reinforced, pervious concrete, waterproof concrete, temperature-controlled concrete, and colored concrete. Some of the popular branches of smart concrete are transparent concrete. Transparent concrete can be seen as recent answer to the architect's call for more transparent architecture. The transparent concrete mainly focuses on transparency, and its main objectives are self-monitoring, environmental protection, and energy saving. Self-healing concrete. Self-healing concrete could solve the problems of concrete structures as well before the end of their service life. The first self-healing concrete products are expected to hit the market in 2 years' time and are expected to increase the lifespan of many civil engineering structures. Pervious concrete. Pervious concrete can be defined as an open-graded or nor-fines concrete that allows rainwater to percolate through the underlying subbase. The principal ingredients are quite similar to the conventional concrete: aggregate, Portland, cement admixtures, fine aggregates, and water. Bacterial concrete. Bacterial-induced calcium carbonate or calcite precipitation can be used as an alternative for concrete and synthetic material. They are environmentally friendly, crack remediation, and hence improvement of strengths of building materials. Moving on to the benefits of smart concrete, it has the benefits such as self-sensing property, with mechanical properties having identical lifespan with concrete. The maintenance and installation are quite easy. It has been found that even by adding carbon fiber, the extra cost of materials will increase by 30%. But this increase in cost of materials is still cheaper than inputting sensors into the structure. It has other benefits like filling the cracks in the concrete and also reduces the permeability in concrete. One factor that they contribute to the global smart concrete market is the widespread use of concrete as a composite materials and its inability to withstand tension. That necessitates monitoring for cracks to allow timely repair. Other methods to evaluate cracks are by attaching or embedding sensors into structures. Sensors, however, cost more to install. Smart concrete has many potential applications in a variety of fields such as traffic sensors, electromagnetic shields, constructions, and etc. So, how smart concrete is used in traffic sensors? Smart concrete is used in road pavements to carry out traffic sensors and weighing vehicles. The advantage of the technique is that the weight of vehicle can be determined even the vehicle is in motion. According to Dr. Chung, the electrical resistance of smart concrete decreases reversibly with increasing stress up to 1 megapascal and is independent of speed up to 55 miles per hour. Next application is electromagnetic shielding. For that, low voltage current is used and electromagnetic radiations are absorbed or reflected. Other applications are transparent concrete for floors and pavements, partitions walls, and it can be used where the sunlight does not reach properly, in furniture for decorative and aesthetic purposes, light sidewalks at night, lighting indoor fire escapes in the event of a power failure, illuminating speed bumps on railroads at night, low-cost and durable roads, low-cost durable housing, high-strength buildings with more bearing capacity, long-lasting river banks, and building highways. Even though there are many advantages for smart concrete, there are some disadvantages like making and recycling carbon fiber and carbon nanotubes are difficult and are very expensive. Moving on to the conclusion of smart concrete, we have so far learned that smart concrete can be used as a self-sensor. It lasts as long as the structure remains. The change in resistance is measured to determine the deformation upon loading, and it finds application in numerous other fields. The growth in the smart building market is likely to encourage the quick uptake of smart concrete. This is because, in addition to their basic functionality of detecting minor cracks, smart concrete also helps to arrest the progress of cracks, reinforcing them to make them stronger. Further, it takes a lot of force for smart concretes to bend, and it is able to accept more energy before fracture. Here are the references. Again, my name is Archeline from Civil Engineering Department, Section 1B, and thank you for listening. Have a great day.